My name is Chuck Trader, and I am proud to represent Camden County School System. I am an 8th grade collaborative math teacher at St. Mary's Middle School. Today our lesson is System of Equations, Solving by the Graphing Method. Today's essential question is, how can you use graphing to solve a system of linear equations? This is part of Georgia Standard M8, A5, elements A, B, and D. Right now my students are actively searching for a graph of a linear equation that was given to them on a 3x5 card on their way in the door. This skill is a foundation to mastering the standard of today's lesson. My collaborative class and I are excited to present you with this video. Please enjoy. Okay, all right guys, now go ahead and clear off your desk. Everything but your math notebook and a pencil. That's all you're going to need right now to get started. Okay? Yes, sir. All right. Good. Turn your clickers on. We're going to take attendance with the clickers. Okay? All right, let's get everybody locked in. All right, good job. Good job. We're good? Okay, good. All right, guys. Now, we're going to do some stuff on the desk, so go ahead and put your clickers underneath your desk. We're probably not going to have a chance to use them today. We're gonna probably end up taking a little assessment tomorrow, so go ahead and put those under the desk. Okay, guys, before we begin, I've got a couple words from a couple special guests.
Hello, class. Mr. Trader wanted me, Albert Einstein, and my friend Mr. Winston Churchill to help introduce his lesson today. Mr. Churchill, can you help get the students going? Mr. Trader does not have much time.
Yes, Mr. Einstein. Now, students, please get out your notebooks. Add to your table of contents pages 60 and 61 with the title Solving Linear Systems by Using the Graphing Method. Complete the top of page 60 with the title and the essential question.
As you can see, today's essential question is: how can you use graphing to solve a system of linear equations? This Georgia standard information should be put in your notes.
Well, Mr. Trader, this is your show. We will watch you do your magic. We enjoyed helping you again today. Goodbye.
The essential question for the day: how do we use graphing to solve a system of equations? Now, Georgia Standards M8, A5. Students will understand systems of linear equations and inequalities and use them to solve problems. Great job, Jaya. Now, there are elements to each of that. Okay, there are three elements. Given a problem context, write an appropriate system of linear equations, which is what we're going to do today. Solve system of equations graphically, which is what we're going to do today. And interpret solutions in problem contexts. Okay? You guys good? Yes. We ready to go with that? Ready. Okay. Now we got some new vocabulary. Primarily, there's just one vocabulary word that we have to worry about. Most all of these we've already had. But what we're going to have to do is we're going to solve system of equations, a definition of vocabulary. Can you please read that, Daniela?
Two or more equations that together define a relationship between variables.
Two or more equations that together define a relationship between variables. Two or more. Can that be 3?
Yes.
Can it be 4?
Yes.
Can it be 5?
Yes.
Can it be 1?
No.
Okay, 2 or more. Now I just want to do a real quick review of some of the vocabulary. Variable. Hand in the air. Jonathan, what's a variable?
A variable is it's a letter that takes place of a number that you don't know.
It's a letter that takes the place of a number that we don't know. And isn't that what algebra is all about? Yes. We take what we know and we find what we don't know. Okay, and we have been doing that all year long, right? Yes. We have been doing that all year long. Sometimes we've done it with a single variable. Sometimes we've done it with a Two variables, right? Okay, all right. Coefficient. Who wants to take a run at coefficient? Hunter, I'm going to call on you. What's the coefficient?
It's like the number before the letter.
The number before a letter.
The variable.
Is that a coefficient, Austin?
No,
No, why not?
because it has to be a multiplication problem.
Coefficient has to be a multiplication problem. Let me ask you this. Would 2 be a coefficient of x?
Yes.
Why?
Because they're multiplied together.
Good. Can I write it any differently?
Yes.
Could you come up and write it, please? Okay. Tell me whether or not she's right. Okay. Is she right?
Yes.
Okay, good. You're all right. Okay, good. Okay, well, we know what slope is. There's a couple names for slope, though, right? Keenan?
Change of rate of change.
Rate of change, okay, and we really have to focus, remember, on slope on rate of change, and that's important when we do word problems. It's very important when we do word problems. Okay? All right, we all know what the x and the y-intercept is. We're not going to review this. This is information that we've had before. Now let's talk about how we solve a system of equations. A system of equations is by finding the point where two or more equations intersect. By finding the point where two or more equations intersect. You all know how to graph one equation. We've been doing that for a long, long time. Unit 4 is where we started to graph equations. Some of you even had it since 7th grade. But when I have two equations, the solution is where the points meet. Where the points meet. And we've learned how to graph equations in a number of ways. Correct? Can somebody tell me 2 of the 3? Kevin.
Input-output table, x and y input.
The input-output table and the x and y intercept. Can somebody give me the last one? Tyler. Slope-intercept form. So we've learned 3 ways. And it's very important that you understand how to do those 3 ways because some of them are going to be easier than others depending on the problem application. Okay? Slope-intercept, x and y intercept, input-output table. Okay, now when you're dealing with a system of equations, there are 3 types of solutions. The first one is one solution. And one solution is when the 2 points intersect, the 2 lines intersect, you end up with a point of intersection. It's referred to as POI. Now I've actually graphed these 2 equations up here. And when I take a look at where they meet at a point commonly known as an ordered pair, right? What's an ordered pair mean?
It's a location.
Jaya.
The location of x and y.
Okay. Can somebody tell me how to graph it? Kamari.
You would go to the right one and then up 3.
Great. So I get my ordered pair, 1, 3, but how do you know it's a solution?
Check.
How do you know? I'm going to call on somebody that hasn't answered here. Rowan.
Would you plug it into the equation to see that?
You would plug it into one equation? You would plug it into both equations and make sure. Now look at the smiley face. Now when you show your work like this, it makes your teacher happy. Okay, we want to keep Mr. Trader happy. Okay, so here we go. We know that there's one solution. Now the other way that you can solve or take a look at by using graphing is you can find a situation where there is no solution. Where there is no solution. Now can somebody tell me what they've learned about lines where they never cross? Tyler, the slope is the same. Well, that's 1. Bradley, they're parallel lines. They're parallel lines because of the definition of parallel lines is what, Bradley?
They're the same. They have the same slope and they're the same line, they just have different y-intercepts.
Hey, fantastic. They have different y-intercepts, but they have the same slope. They have the same slope, they have different y-intercepts. They don't meet. So if lines don't meet, do they have a solution? No. No. So there's no solution. No solution. Let's take a look at the next. Infinite solutions. Infinite solutions. Can you please read that for me, Kayla?
A pair of equations that have the same slope and y-intercept, they are the same line and are called coinciding lines or coincidental.
That's right. That's kind of a hard word to pronounce, isn't it? Coincidental lines. Okay? Coincidental lines or coinciding lines are lines that are on top of one another. Okay? Now, a line is nothing more than accumulation of what?
Points.
Points, right? Now, if the lines are on top of one another, then you
Have all the same points.
all the same points. That's why there's an infinite number of solutions. Because remember, lines go on forever. Okay? Now, you got to be careful because coinciding lines could look different, but they could still be equivalent in the equation form. What I mean by that is an example might be a fraction of 9/18 is equivalent to a fraction of 8/16, correct?
Yes.
Correct? Because what are they both reduced to? 1/2, okay? Now, it's just like, I tell you, Savannah, if you come to school in a red dress, and the next day you come to school in a blue dress, are you still Savannah? Absolutely. Okay, so you really got to watch that because sometimes the equations, one might be in standard form, one might be in slope-intercept form, but if you graph them, they're going to look the same on the graph, right? Okay. Any questions so far?
Yeah.
Okay, so if we're going to summarize, we have a solution of graphing equations. There are 3 ways to solve them with 3 answers, right?
Yes.
One is what?
X and Y.
No, not graphing. What's the first way? Is there a solution? There's one with one solution, right? And that is the point of intersection. POI. A lot of times it's called POI, point of intersection. And then there is the no solution. Good. And then lastly there is the infinite solution. Good. Good. Okay, so here's some examples. Now take a look at that. Take a look at that. Take your time. I'm going to give you 30 seconds to tell me whether that's one solution, whether it's no solution, or whether it's an infinite solution. Yeah. Come on, I know some of you can't do this in your head. I need to see you work on paper. Bradley, you got it already?
I got the first one, it's infinite solutions.
Oh, infinite solutions? How'd you get that?
Because you can move the x over, and then when they divide it,
Move the x over?
you move the x over, and when you divide the 2 on the y by everything, it turns out to be the same.
Okay. Kevin? Okay, Kevin, well, why? Why do you think it's wrong?
Well, when you move the X over, you get 2Y
yes, negative.
equals a negative X plus 6, but then you got to divide by 2. So X would be 1/2.
Okay, so what's your answer?
Oh, no, I mean, not one solution, but one solution.
One solution, very good. Bradley, do you see that? Do you see that? Remember, if you have a coefficient of a y and you're trying to put it into slope-intercept form, you have to make sure that you divide everything by that coefficient, right? Okay, what about number 2? Tyler's back there. He's already got it. He's probably got all 3 of them done. Okay. All right. Hope, what do you think?
There's none.
No solution. And how do you get that? Why do you believe that's the case?
They have the same slope.
They have the same slope
And y-intercept.
and the same y-intercept. You see that? Good. Okay, that is infinite solutions. Okay, how about number 3? All at once. All right. Process of elimination is what most of you used, right? Yeah. Okay, all right, good. Okay, but do you see why it doesn't have any solution?
Yes.
They have different
Y-intercepts.
y-intercepts, but they have the same slope. Good. Good, okay? Any questions so far? We're good. I think most of you are grasping this pretty good. Here's some more examples. Okay? Let's just take a quick look at these. I want to see some people write this down on paper because remember, I want to see you guys show your work. And when you take something and you have to put it into common form, you got to show your work. Good. Good. I really like what Kayla did. Kayla realized that this is in what form?
Standard.
And you all remember that if I wanted to take something that's in standard form and I wanted to find the slope, okay, standard form is AX plus Okay, and if I want to find the slope, you learned that the slope in standard form is negative A over B. You're dividing coefficient of A by a negative because you would normally cross the equal sign, change the sign, and then you're going to divide it by the coefficient of Y. Okay? Now, can anybody tell me what the y-intercept is? Go ahead, Keenan.
It's C divided by B.
C divided by B. Good, good. So a lot of times you can just, the same as y equal mx plus b. You know that m is the slope and b is the y-intercept. Okay, good. So if we take a look at this, do they have the same slope?
Yes.
Yes.
Do they have the same y-intercept?
Yes.
So it is what? Yeah, good. How about the next one?
No slope.
Should be an easy one.
No.
One solution. How about the last one?
No slope.
Process of elimination again? Okay, I want to see some work. Come on, jot it down real quick.
It's no solution because you got the same slope but different.
Look at it very closely. No solution. No solution. Okay. All right. Structured notes. Okay, I've got some structured notes for you, so let me pass these out. Okay, I got some more that are back there on my desk. Let me go back and get them. Okay, structured notes. Okay. I want you guys to make sure that you finish these, and I want to see them in your notebook. Okay? Just glue them in like we normally do. Okay? Now, you've got some blanks in there. I have filled in the blanks with boxes for you. Okay? These are the steps for solving word problems. These are the steps for solving word problems. Okay? The first step. The first step. Hunter, can you read the first step for me?
Indicate what each variable stands for.
What does that mean? What does that mean? Austin?
It means in a word problem, you need to find out, you need to list what your x's and y are going to stand for.
That's exactly right. You need to list what your x's and y's stand for, right? Now, are they always x's and y's?
No.
Not always. We found that out a number of times. We found that out a number of times. A lot of times so you can keep consistent with identifying what you're actually solving for in the problem. Step number 2, write a system of 2 equations that can be used to solve the problem. Okay, you guys got that blank filled in?
Yes.
Why do I have to have 2 equations?
Because
It's a system of equations. And a system of equations you really can't solve unless you have 2 equations. Unless you have 2 equations. Okay, step number 3. Solve the system showing all the steps. Solve the system showing all the steps. Now guys, I want to see your work. When you take shortcuts, you start to make mistakes. Okay? 4, check your work in both original equations. Now why do I have to check both equations?
Because if it works in one, it doesn't mean it's going to work in the other equation.
If it works in one, it doesn't mean it's going to work in the other equation?
Yeah, you have to check both.
Okay, so, and what would that identify? It'd identify that you did what?
Check out your rolling steps.
Okay.
Yeah.
All right, Kayla. They've called for you. They've called for you. You're dismissed. Okay. Yeah, they called for you. Okay. Hey, listen, have a great weekend. Okay? All right. Good. Okay. All right. Step number 5. State your solution in sentence form. Now, when you solve a problem, okay, I want to know what your answer is. Okay, I don't want to know that x is equal to 5 and y is equal to 6 because that might not tell me what the answer is, right? Great. Hey, listen, we'll see you. Have a great weekend. That might not tell me what the answer is. So I need you to state your solution in sentence form. Questions? Okay, good. All right, you got this? Keep it in your notes. Refer back to it when you're solving some of these problems. Okay, let's do a teacher-led instruction. Okay, I'm going to read this out loud. You follow along. Kara's candles. Kara likes candles. She also likes mathematics and was thinking about using algebra to answer a question that she had about 2 of her candles. Can you see okay? Her taller candle is 16 centimeters tall. Each hour which it burns makes the candle lose 2.5 centimeters in height. Her short candle is 12 centimeters tall and loses 1.5 centimeters in height for each hour it burns. Now, Kara needs your help. Kara needs your help. Kara didn't take algebra. So Kara comes to me and she says, could you take this problem to your algebra class? Could you take this problem to your algebra class? And could you have them help me solve it? Could you have them help me solve it? Okay, so the first thing, take a look at your steps. Take a look at your steps. What's your first step? Okay, all right, I want you to jot that down in your notebooks. I want you to jot that down in your notebooks. And while you're doing that, I'm going to pass out some graphs that we're going to be using. Okay? All right. Some of them still have lines from when we used them before. But what I want you to do is I want you to either use the lines or you can use your, you can use the lines or you can use your, you know what, I don't have enough of these for everyone, so I was going to give you each pair one. Okay, good. Okay. Now, you might have to take the tape off, right? Because these might not be the right equations. Okay, so let's analyze this problem. Step 1 was? Okay, good. You good with that? Okay, everybody has that down. Okay, everybody has that down. Adasia, what did you identify?
Y equals negative 2.5.
What's y?
Y is
2.5 what?
It's negative 2.5 x plus 16.
Ah, negative 2.5x plus 16. How did you get that? Could you explain that to me?
Because she has a 16 centimeter candle and it burns. If for each hour it burns, it loses 2.5 centimeters.
And what do we learn about slope? It's your what? Rate of change, right? So if my candle's burning, is it growing?
No.
So it's shrinking, so it better be a negative slope, right? Okay, and my y-intercept is?
16.
Why?
Because that's how
That's how tall it was. Okay, good. Adasia, very good. That's a big cat ticket. That is a big cat ticket. Very good. Okay, now let's take a look at what the second equation might be.
Y equals negative 1.5x plus 12.
Okay, good. Same situation, right?
Yeah.
Okay, now, can you guys graph that?
Yes, sir. We can put it into a fraction.
You have got it. That's another big cat ticket, okay? Why do we need to put it in a fraction? Why? Rowan? Because you can get your eyes overrun. Because if I took a look at 2.5, I could still put what under that in the denominator? I could still put a 1 underneath it, but we find this a lot easier if we change it, okay? So I'm going to take this, and what is that going to be with a fraction form?
Negative 5 over 2.
Negative. Y equals negative 5 over 2 plus... Okay, and the second one would be what?
Negative 5 over 3.
Hey, big cat ticket. Man, you're gonna pop these up. I love it when you guys catch me in a mistake. Okay, what's the second equation?
Negative 3 over 2x plus 12.
Okay, I want you guys to please graph that. Okay? Now, it might... What? Who said that first?
Me. Everyone.
Everyone. So everyone gets big cat tickets, huh? Oh, well, I don't know. I think I heard it from over here first.
I said Mr. Trader.
Okay. What's that? Okay, all right, good. Okay, so let's take a look at that. Let's take a look at that. Now, I'm supposed to lead this, right? Teacher-led instruction. But I want you to follow along. When you graph something, when it's in slope-intercept form, what are you going to put on your graph first?
Your y-intercept.
Yeah, your y-intercept. And then you find a second point by how? Yeah! So guys, do that really quick. That should take you about 1 minute to do both of those. 1 minute to do both of those. Okay? So the y-intercept on the first one is 16, right? So you're going to put your mark right there. And then your slope is negative 5 over 2. So you're going to go down 5, right? And then over 2. And you got your line, right? Okay. That's not perfect, right? Now, on the second equation, what's your y-intercept? And what's your slope? Down 3. Can you do that? Down 3 and over 2? Okay. Now, can you draw a line? Can you use a what? I would just use a marker. I would use a marker. Okay? All right, guys. Good. Okay. Now, both of your lines better be going in what direction?
Down.
They better be going from left to right. They better be going down. Okay? Does anybody need any help? Check your neighbor. Check your neighbor, okay? All right. Now, which one out of the group has the birthday of the first closest to January 1st? Okay, the first one earlier in the year, you're number 1. Okay? The one later in the year is a number 2. Okay? All right, 1s, raise your hand. 2s, raise your hand. Okay, nobody has 2 1s in the group. Nobody has 2 2s, right? Okay, good. All right, okay. Okay. Huh? It's a system of equations. Should you do just one? Well, wait, let's look. Hey, how many of you went back to your structured notes? All right, good. Some of you did. Good. Why do you think I give these to you?
So we can learn.
Yes, write a system of 2 equations. Now it's going to be solve the system showing all steps. Check your work in the original equations. Now, what happened when you graphed those 2 equations? In what do you call that place where they intersect? The POI, which is a point of intersection. Okay, so anybody get a point of intersection?
Yes, we did. The point of intersection we got was 4, 6.
4, did you check your work? Did you check your work? Come on, I want to see it step by step.
I'm checking it now.
Huh? You got it? Okay, all right. Now some of you that use the tape, it's off a little bit. It's off a little bit, but that's okay. All right, now let's take a look at this. She wants to know if these candles will ever reach the same height. What do you think?
Yes.
Yes. Yes, why? You just graphed it, didn't you?
Yes.
Yeah. And they're going to reach the same height at what point?
6.
Yeah. Oh, wait a minute. Now you guys are giving me the hours. What are you doing? Okay, somebody must have made sure. Okay, good. All right, she also wants to know what height the two candles would be at the same time. Okay, so it looks like, what did you use for the x-axis back here?
4 hours.
Hours, which is a measure of time. Okay? So I would assume that when you actually did step number 1, indicate what each variable stands for, x would be equal to time, okay? All right, so what do you get for y? Caitlin, what do you get for y? What did you use? What did you identify for y? What is y on your graph? What is y? Huh? Well, okay, but what does 6 mean? It's how tall it's going to be. It's how tall it's going to be. Okay, so that means that where those lines cross, it's going to be 4 hours and it's going to be 6, right? Okay, good. Good. Okay, now it says multiple representation. Now, how can I do it besides graph, guys?
A table.
Oh, a table. Well, it just so happens that I have a table for you. Okay. Now, this is what occurs. I put the input is x, which is my time, and my output is y, right?
Yes.
And remember, y was 2 equations, right? Y was 2 equations. So what I did is I plugged in one for x, I solved for y. Okay? I solved for y in both situations. In both equations. I put in 2. Okay? Which one's got the greatest rate of change? What do you think? What do you think? Raise your hand if you can tell me what the rate of change is. Raise your hand. You can tell me the rate of change for both of these. Come on, everybody ought to have their hand up. Okay, which one has the greatest rate of change?
The first one.
The first one. Why? Okay, big cat ticket. Okay, good. Can you pass that back? Don't you stick that in your pocket. Okay, so now when I get down and I've got x is equal to 4, what do you know about y? It's equal, right? It's equal. Okay, Jonathan, do you see that? Now, can the 7 work?
No.
Because
one's negative.
Can I have a negative candle?
No.
Okay, good. I can't have a negative candle. Good. You guys see that? That's another representation. Okay. Now, I want you guys to stretch your mind, okay? Now, when you take a look at this, that mind is about where you are now, right? But I want you to stretch your mind. So I have really 3 problems up here. I have a level 1 problem, I have a level 2 problem, and I have a level 3 problem. I want you to pick the most difficult problem that you can solve, and I want you to work it out. Work it out on your graph. Work it out on your graph. Now, what I want you to do, Audrey, I want you to go ahead and pull up here so you don't have to work alone. I want you, this is a group project. This is a group project. I want this to happen. I want the 1s to take one of the equations, Jonathan, and I want the 2s to take another equation. Okay? So I want you to work together. I want the 2s to check the work of the 1s to check the work of the 2s. Okay? You've got 3 minutes. No, you're going to use your, go ahead and use your graphs, okay? So you've got one graph, so what you're going to have to do is just talk about it. Let's just talk about it. Talk openly. You're going to have one graph, but one put together the first equation, one put together the second equation. Which problem did you pick?
The level 3 one.
All right, we got Austin over here that picked the level 3 one.
I did too.
Okay, did he? Good. Okay, good. Okay. Hey, when we learn, we got to start where? We got to start with the basics, okay? We want to not necessarily pick the hardest problem that we don't know how to do. We want to pick something that we do know how to do, and then as we go through learning, we make it a little bit harder. Okay, how you guys doing? Raise your hand when you got your equations written. Which one did you pick?
So when I'm doing this, it has to be the
Oh, good. So what did you pick x to be?
X was the children. I mean, X was the adults and Y was the children.
Good, and why? Why? What's that mean?
5X,
Yeah, what's a 5 mean?
the price for the adults.
Ah, good. And what's a 3 mean?
The price for the children.
Good. And x means? The number of?
Tickets.
Yeah, what kind of tickets?
School play tickets.
But the adult tickets, right?
Oh.
Okay, good. Okay, all right? Good. We'll help you. We'll help you. Come on. Now, guys, we're not going to, obviously, we're not going to have time to use the graphing calculators today. And I know that we've gone here, and many of you have seen this, GeoBra. Okay, it's interactive, okay? And again, we can use this to solve this, and some of you have used this at home. But of course, we can change the slope. We can change the slope by moving this. We can change the slope. Okay, we can also, that's the red line. We can also change the y-intercept. Okay, so we can use some technology when we do this. We can use some technology. We can also use Mr. Elmo over there, right? We can use Mr. Elmo over there. We're not going to have time to use him today. Okay, we can use the clicker systems, which are going to move tomorrow. Okay, could you please stand up? Where's your graph? Where's your graph? Talk loud now.
First, since we had two equations, we put both of them, because we had to graph them, in slope-intercept form. So we graphed both of them once they were in the slope-intercept form, and we found the point of intersection, which was 310. So, and then x and y stand for the prices of the tickets that were in the problem. So it'd be $3 for the adult ticket, and then $10 per student ticket.
So how do you know? How do you know you're right?
We plugged it in.
You plugged it in one equation?
We put both of them.
You plugged it in both equations. All right. Let's see. What problem was that? 3 tickets apiece. All right. 3 tickets apiece. Good job. Anybody else? Anybody else?
We're almost done.
Okay. All right. Anybody else? Okay. Let me go around. Who's having trouble? Who's having trouble? Let me come help you. Okay? All right? Good.
I don't know which way it was.
Yeah. So you've got, okay, let's take a look at that. You can do this with your x and y intercept. Do you remember how to find the x and the y intercept? Kevin, you going to hold it up?
I'll hold it up.
Okay. Now, if you didn't check your work, I don't want you to come up. Okay, go. Talk loud, Kevin.
Just stand right there. Basically, well, we did this one, and
Come over here so we can hear you. Okay. All right. You're on the. No, go ahead. Go ahead. Go ahead.
Okay. We did the level 3 problem, and what we did first was, well, he did this part, but we wrote down what everything was, like the total was 45, and basically what x and y were represented by, like 5 and 3. And after we did that, we made 2 equations, and the equations were x plus y equals 13, so that's how many tickets they sold, and the other one was 5x plus 3y equals 45, and the total was 45, and $5 for adults, 3 for...
Okay, good. Yes, ma'am?
Could you please Asia off?
Say that again?
Adasia?
Yes, 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 okay.
The 7th grade office, please.
I sure will.
Thank you.
Okay. All right, Adasia. Grab your planner. Okay, good, good. And you checked your work, right?
Yes, sir.
Okay, good job. So how many tickets do you get? 3. Okay, good job. All right, good job. You guys might get ice cream for this, you know. Okay. All right, guys, good. Any questions? Any questions?
We stretched our mind.
Okay, did you stretch your mind?
Yes.
Okay, do we need to summarize?
No.
How many solutions are there? 3. What are they? 1. No. Infinite solutions. Say, oh yeah.
Oh yeah.
Good, okay, all right, guys, good. Hey, I think you guys did a great job. Now. Here we go. We did the candles. Let's do this. Show me what you know. Show me what you know. Now I will tell you, what you're going to show me what you know is you're going to do your homework. Okay? Now I'm going to have a level 1, level 2, and level 3. Okay? I'm going to hand out the assignments to you. Okay, some of you are going to have level 1, some level 2, and some level 3. Now remember, use your resources. Use your resources at home. How many people have used Study Island? That's a great tool.
I love that website.
Okay, it's a great tool. Now tomorrow, I'm going to give you guys a formal assessment by using Study Island and the CPS clickers. Okay?
Okay.
All right, so I want you to be prepared for that.
Yes, sir.
I want you to be prepared for that. Okay?
Okay.
All right, guys, take it out the door. I want you on a half sheet of paper. I want you to write for me. How can you use graphing to solve a system of linear equations? Okay, I want to know that you have understood, that you have got the knowledge of answering the essential question. How can you use graphing to solve a system of equations? To solve a system of linear equations. Okay? All right, you guys can put it on a full sheet if you will. You don't have to rip it in half. And then I'm going to come around and I'm going to hand out the homework. Okay? I'm going to come around and hand out the homework. Level 1, exercise A. Level 2, exercise B. Or level 3, exercise C, as I assign them to you. Okay, so while you're doing that, go ahead and weekend unless you get this done. Okay, all right, guys. Listen, I've been to Tyler's house. I've been to Tyler's house before helping him.
I'm going to... Oh, here you go.
Okay. All right. Okay. All right, guys. Any questions? Any questions? Okay, guys, did a great job.
I need Savannah Prescott and...
Great. Hey, listen, I'm glad you're back. Have a great weekend. Okay, Ryan, Kevin, have a great weekend. Got a track meet tonight?
Yep, tomorrow.
All right, good job. All right, Kayla, good job. Did that help you? Did it help today? Good job. Good job. All right, Keenan. Jesse, did that help? Good. Great job. All right, Hunter, did that help? Okay, Anna, you're good with that? Okay, good. Kayla, thank you. Jonathan, did you give me one? Okay, good. All right. Good job. Hey, guys, have a great weekend. Tell your mom hi. Okay, listen, we'll see you guys. Hey, guys, we'll see you. Have a great